Stanford University.
Okay, well, welcome to lecture 13 of Stanford CS 193P, spring of 2016. Today we're going to be talking about animation primarily. I'm actually going to show you a little class called NSTimer first, which we really don't use for animation, but when we're doing animation, surprisingly, we end up using NSTimer sometimes, not for the animation itself, but just because animation is a timing-based thing, and NSTimer obviously is a timing-based class. And then we're going to dive right into animation, and there's lots and lots of mechanisms for animation in iOS, and I'm only going to show you, 2 or 3 different ones. I'll talk a little bit about what things there are, but I'm only going to dive into a few of them. And one of them, the simulated physics version, I'll get started on the slides today at the end, but I won't make it all the way through, and I'll just continue in the next lecture. Okay? All right, so let's take this little detour and talk about NSTimer. NSTimer is a very simple little class that allows you to call a method periodically. Okay? And you can either have it repeating, where it's calling it over and over every certain amount of time, or you can actually just have it call it once sometime in the future. Okay, so it's a way to set up a timer to call a method. It couldn't really be simpler than that. Again, we're not going to use it for animation, things moving around and stuff. There's other mechanisms for doing that, but you're going to see from the demo I do today where NSTimer kind of can come in and be used. It's actually quite useful in a lot of situations. It's not a real-time timer. This is not a real-time operating system. You got that main queue. Other blocks might be executing off that main queue, and so the timer's trying to execute, but it can't because it's busy. So it could be off a little bit, but it's generally going to try to call this method when you say. The timer is built on a mechanism in iOS, which I'm not going to talk about at all in this class, called run loops. For the main queue, there's a run loop set up for you, so NSTimer always works on the main queue. For other queues, you may or may not have a run loop. You might have to set up your own run loop, etc. So for the purposes of this class, just assume NSTimer is a main queue thing. Of course, when the timer goes off and calls a method, you could dispatch async to another queue in that method. That's fine. It's just that the actual firing of the timer, that has to be happening in the main queue for the purposes of this class. Okay, so what's the main method look like in NSTimer that does this? This is it. So you have to schedule timer with time interval. Notice that it's a class method, right? A static method on the class. So you invoke this by saying NSTimer dot schedule timer with time interval. And you just specify how many seconds from now you want this timer to go off for the first time. And then you specify a target and selector. That's the method in the object that you want to be called. You got this user info. That's basically a cookie. Right? You can put anything you want in there, some context, whatever. You can leave it nil if you want. And then repeat is whether it's going to go off again in this many seconds at the beginning there, and just keep going off over and over and over. Okay? So it couldn't really be simpler than that. So here's an example of calling it. All right, I'm calling it for it to go off in 2 seconds there. You see, 2 seconds. And I'm going to call a method in myself called fire. It has one argument. We'll talk about what that argument is in a second. And then here I'm not passing any context or cookie or whatever right there, just nil. And this one's going to be repeating. So every 2 seconds, this method fire is going to be invoked in self. And so let's go ahead and look at fire with this argument and its timer in there. Here it is. You remember from the selector syntax up here, this hashtag or pound sign, whatever hashtag we call it now, pound sign selector fire. See this little underbar colon there means it has an argument, and that argument for an NSTimer is always the timer itself. Okay, so that's the timer that is sending you this fire method down here, and inside of the implementation of this fire method, you can get this cookie that you gave it up here, where now it's nil. But if I put cookie up there, I can get it back by accessing the user info var on the NSTimer. See? So that's how you get the cookie back. Because remember, this timer is going off some number of seconds or even minutes later, and you might want that timer to get that cookie back at that time. Okay? Now, what if you have a repeating timer and you want to stop it? How do you do that? You call this method on the timer called invalidate. Now, a little bit of a warning, if you call invalidate on a timer, that timer is no longer valid, and you should not do anything with it. You can't restart it, really. There's nothing you can do with it. And so it's usually a pretty bad idea to have a strong pointer to an NSTimer. Okay? Because you got the strong pointer, you invalidate it, now you've got a strong pointer to something that's invalid. So it's much better to make your pointers to NSTimers be weak. And when you do that, if you hit invalidate, no one will have a strong pointer to it anymore, and it'll leave the heap, and your weak variable will get set to nil. So I recommend using weak pointers to NSTimers. Or not having any at all, because remember, every time it fires, you get this timer passed back to you as the argument, if you want it. Okay? Tolerance. So you can specify in the timer a tolerance, and that's basically how much you're willing to accept some slop in its calculation of when it goes off. Okay? So here I'm talking about an example where you have a timer goes off once a minute, you set the tolerance to 10, which is in seconds, and that means, if it goes off after a minute, that's fine. A minute and 3 seconds from now, yeah, okay. A minute and 7 seconds, fine. But a minute and 20 seconds, that's too long. All right? And so why would you want this tolerance? Well, because other things are going on in the system. And if you really don't care about getting it right on time, then maybe the system can be more efficient about how it's using its processor and other resources during that time. Okay? And notice that this tolerance does not cause drift. So if the first time it goes off a minute and 7 seconds after, the next time it's going to go off, try to go off 2 minutes from the beginning. And the next time, 3 minutes from the beginning. You see what I mean? It's not drifting. If it's late on one, it doesn't start being late on the next one. All right, so let's do a demo of this so you can see it in action. What I'm going to do here is I'm going to take our old friend Faceit. Okay, remember Faceit there? And we're going to make it so his eyes blink. Okay? And we're going to do that using a timer. So it's pretty straightforward, actually, to do this. I'm going to use this opportunity to teach you something else. Okay, I always try to do that, which is what if I had this MVC right here? If you look at this MVC, if we look at the identity inspector for it, you can see that its class, of course, is FaceViewController, right? Remember our FaceViewController? It's got all this stuff. Our FaceView, it's got all those gesture recognizers, you know, all this stuff. Remember that? So that makes sense that that's what the controller is for this. What if I wanted to put all my blinking stuff in another class? In other words, I didn't want to put blinking in with all this other FaceViewController. Okay? In other words, what if I wanted a blinking FaceViewController? Okay? Well, you can use inheritance. This is object-oriented programming. It's not uncommon to create a subclass of another MVC's controller to create a controller you want for your MVC. And that's exactly what I'm going to do. Okay? I'm going to create a new controller here. It's a new file. Okay? To iOS source. It's a Cocoa Touch class. But instead of the subclass being of some UIKit class here, it's going to be a subclass of my class, FaceViewController. Okay? And I'm going to call it Blinking FaceViewController. All right? So here it is. It's creating it, putting it in all the regular places where it puts it. Here it is. I don't need any of this stuff, so I'll get that out of there. So I've got this Blinking FaceViewController. It's a subclass of FaceViewController. And in my storyboard, if I went to this and changed in the identity inspector for this, changed it from being a FaceViewController to being a blinking FaceViewController, and hit run, do you think this would work? Yeah, it would work, because blinking FaceViewController inherits everything from FaceViewController, so it's going to work just as well, because it's full inheritance of it. So let's go back here and remember what this emotions app here does. So we can pick our various emotions, and you can see it's working just fine to have this be a blinking FaceViewController. Of course, it doesn't blink because I haven't put any blinking code in there, but I am going to put the blinking code in now. Okay? I'm going to put all that blinking code up here in this subclass. So this blinking thing is pretty simple. It basically needs a bool here, which is whether it's blinking or not. We'll start it out as false. It's not blinking. And of course, every time this changes, we're going to basically need to start blinking. Okay, someone says that, someone says did set, changes this blinking thing. So I need a little private var here, start blink, and it's going to have to start things blinking. And actually, it's going to want to look at blinking though, and only do the blinking if blinking is true. Okay, if blinking is not true, it's not going to want to do that. Private, this is a func, private func. Okay? So inside the blinking there, it's going to want to start blinking. And we'll talk about how to do start blink in a second. Now, sort of for the purposes of demo, but also to talk a little bit about timers here, I'm actually in my view did appear, okay, super view did appear, animated. I'm not going to start myself blinking, so I'm going to say blinking equals true. It's a little bit demo-ware because you probably wouldn't want a blinking face controller to always start blinking as soon as it comes up. You want to let people, this is a public VAR, and you want to let them control it with that, but it's good for the demo here. And also in view will disappear, I'm going to do the opposite and turn it back off, and we'll talk about why I'm going to do that in a second. Blinking equals false, okay? All right. So we got this kind of infrastructure for our blinking right here. How are we actually going to do the blinking? Blinking is really easy. We're going to start blinking. How do we start a blink in real life? We close our eyes, right? So we're going to have our face view, eyes open, equal false. Okay, we just closed our eyes. And now, after a moment, open them again. That's what we do when we blink, right? We close them and then pretty soon after that, we open them back up again. That's what a blink is, okay? So that's what we need to do. Now, before we talk about how I'm going to do this, let's look at face view right here. This is interesting. Face view, where does that come from? Anyone know where that comes from? Yeah, I inherited it from this guy, from face view controller. If I go back to face view controller, here it is right here, face view. Notice it's not private, okay? Usually we make our outlets private. We didn't happen to make this one private. It might have been an oversight on my part, but we didn't make it private. One of the interesting things about Swift is that there's no idea of protected. How many people know what protected means? Okay, not too many. So we know about private and public, right? Private means you can only use it in this class. Public means you can use it outside the framework you're in. Everything else in Swift is internal, which means you can use anything, anywhere inside the framework you're in, including your app is kind of like a framework. So this face view is really available to any class that's inside our app, okay? And so that's nice, but it would be maybe better if there were another protection class called protected, and what that would mean is only subclasses can use this thing. Because that's really what I'd like here. Face view, I really don't want other classes, even in my app, thinking they can start mucking with my face view, okay? But I want to be able to allow people to subclass. So unfortunately, you can't do that. So if you want something to be subclassable and used in a subclass, you have to leave it internal, okay? So we're going to leave that internal. That means we can use it here to open the eyes. Or to close the eyes. Okay, so now how are we going to do this thing where we wait a moment and open them? Well, I'm just going to use timer, of course. That's why we're here. So let's some space here. NSTimer. It's called scheduled timer with time interval. Notice there's two of them here. See this one and this one? You don't want to use this one. This one has an NS invocation, which is really just a wrapper for calling a method. But I'm not going to show you that. You don't really need to know it because this one's just as good right here. This one's target and selector. This is what we saw on the slides. So here it is. To make this a little more easy to see here, I'm going to add some carriage returns here. Okay, so here's our scheduled timer with time interval. So we need a time interval. I'm going to be a good programmer here, and I'm going to create a little constant struct here. I'm going to call it my blink rate. And so I'll have a static let here, which is the closed duration, which will have be, I don't know, you close your eyes for less than half a second, something like that. And then we'll have our open duration. Now this really doesn't want to be a constant. If you think about how you blink, you don't blink and then exactly 5 seconds later you blink again. Okay, you seem like a robot. Unfortunately, this is kind of a robot. So this really would probably want to be some sort of function, you know, that kind of, I don't know, does some statistical distribution of your blinking, but we're just going to make it be 2.5 seconds, okay, so we can see this guy blinking pretty quick. All right, so he's going to keep his eyes open for 2.5 seconds, close them for 0.4. So here, the eyes are closed, so we want the interval that we're keeping it closed before we open it again. So this is going to be our blink rate dot closed duration, okay? The target is going to be our self. Now, there's a restriction on this self, the same restriction that we had with the other # selector type of APIs, which is that this class that's receiving this has to be available to the Objective-C runtime. Okay? And so that means it essentially has to inherit from NSObject. Now luckily, self, no problem, because we inherit from face view controller, which inherits from UIView controller. which inherits eventually from NSObject. So we're all good to go here, but just don't get too confused if you try to do this and it's like it doesn't work, because the object you send this message to has to be Objective-C compatible. So the selector we want here, let's call it, this is the start of the blink, so I'm going to call my selector on the other side end of blink. So this is, we're in our blinking face view controller here. End blink, I'll call it, the argument on there. Okay, that's what we're going to call. So we're going to need a method down here, private func end blink. It's going to take that timer as an argument. Okay, we're going to end our blink there. User info, that's a cookie. I don't really have anything to say. It's pretty obvious. I open and close my eyes. And repeat is false. Okay, I can't really have one repeating timer, because you don't blink like this. Eyes closed for 1 second, eyes open for 1 second, eyes closed for 1 second. You know what I mean? They're two different timers. One is the closing one and one is the opening one. So I really need two different timers going back and forth rather than one just going repeatedly. Okay? Is that there? Okay? Make sense? Now, let's take a look here at this error. You see an error right here? I put this in here. It's like, what's the problem here? And it says right here, you have to add Obj-C to expose this method to Objective-C. So I said this had to be an Objective-C compatible method. Well, what the heck? Why is it making me put Objective-C there? And the answer is because I made it private. Okay? Private methods don't get exposed to Objective-C, to the Objective-C runtime. As soon as I made that not private, now it worked. Okay, so note that as well. It has to be public method, okay, or otherwise exposed to Objective-C, which you can do with that @Obj-C as well. Okay, so that's good. Now, another interesting thing about this end blink here is I actually don't need this timer, because I don't have any user info. It's not a repeating timer that I would want to invalidate. Why do I even need that? I don't even need that thing. Get that out of there. And if I get that out of there, then I don't need this. Okay? And that's allowed as well. Okay, just like we have target action, where sometimes we pass the sender along, same thing with the timer. All right, so that's it. What are we going to do in our end blink? In our end blink, what happens when our blinking is ending? We've got our eyes closed. Now we open them back up again. So now we're just going to say face view dot eyes open equals true. And now we want to queue up another blink, because we just want to keep on blinking, right? So I'm going to do that with another timer. So I'm going to copy and paste this right here. This time, though, it's our open duration. This is how long the eyes are going to be open until we start blinking again. And instead of end blink here, now we're start blinking again. Okay? Again, error, because this needs to be public. Okay? Because now we're calling this one. These guys are calling each other. Okay? Is that good? Everyone understand all that? Okay, so let's see if that works for us. All right, here's our guy right here, and sure enough, he's blinking. Okay? And, you know, if we go to other ones, they'll all blink. Got it? Okay, so that's it for timer. Hopefully that's a simple example that shows you how we use timer. So the eye blinking is not really, we wouldn't consider that necessarily animation, but it's kind of involved in the animation, right? And the next demo I show you, we're going to actually animate the opening and closing the eyes. Because right there, the eyes are just popping open and then popping shut, popping open. That's really not animating them, okay? So we'll show that in our next demo. All right, back to our slides here. Okay, so let's do a little overview of the kinds of animation that are available in iOS. Okay, this is most of the kinds. One is there are 3 UIView properties that you can animate the changing of. Okay, which is the frame, the transform, which is like that rotation thing, and the alpha, which is transparency. So you can animate those, and we'll talk about doing that. You can also animate view controller transitions. You notice that UI navigation controller, when you click to another one and it slides another card in, it kind of animates it like a card sliding in, right? Or sliding off. And so there's a whole mechanism for building your own UI navigation controller-like things right, that have little sub UIView controllers that move in and out. And we're not going to talk about that at all because you're not going to be doing that in this class. It's a little bit of advanced design. But when you go out in the real world, hey, you might figure out some way. You know, like I know the Facebook app has a little tray that slides out from the left. Okay, that's something they designed. And it's kind of like a UI navigation controller, but it only slides out part way. Okay, so I'm sure they had to use this mechanism to make that animation happen. Core animation is a non-object-oriented API that underlies almost all the animation we're going to talk about here. Okay, it's the big beast engine that's going on underneath all this that's making it all work. Unfortunately, I don't have time to talk about it. We're going to talk about the higher level things that are built on top of core animation. But you should know it's there. And quite a few people do core animation stuff in their final projects. Okay, it's a good not covered in lecture thing. And there's things you can do in core animation that you can't do with UIView level animation. Okay? There's a window from your UIView into the core animation world, which is the layer. If you look in, there's a CA layer, core animation layer. That's what CA layer stands for. And there's a property in View for that. And that's how you can kind of get down to the core animation layer and start doing core animation things. Like core animation can do rounded rects on the edges of your views and things like that. Masks, all kinds of fun stuff. Okay? If you want to do 3D, there's OpenGL. OpenGL ES bundled with iOS. So how many people here have experience with OpenGL or doing 3D? Okay, so a few of you. So you can do that, full OpenGL support in iOS. There's also something called Sprite Kit, which is like 2.5D. Okay, this is how when you make an animated thing out of images that kind of are overlapping each other and moving around, right? Some guy walking through a castle and, you know, he finds a monster and he's fighting against it. And it's not really being drawn in 3D like OpenGL. It's being drawn with images overlapping, but they're kind of 3D looking images. And so Sprite Kit manages not just the overlapping images and how they all move around each other, but it also can do particles. So you can do things like explosions and fire and all kinds of things. So it's a really great thing for building you know, these 2.5D like animated things. We're not going to talk anything about that in this class. Sorry about it. It's got to be limits, and there's one of them. There's also, for views, dynamic animation. And this is essentially animating using physics. So you assign gravity and collision boundaries and things like that to views, and then you just say, go. And those gravity starts pulling on it, and it hits the boundary, and it bounces off, and things like that, okay? So it's a physics-based animation of views. Okay, so that I am going to talk about. Again, I won't have time to get all the way through that, but I have a big demo on that in the next lecture. But today I'm going to focus on the UIView animation, okay? So the first one is this simple one where you can change any of these three properties, frame, transform, or alpha. These are the primary ones you can change. And it will animate the change, the from, and the to of values of these three properties, okay? So it's done with UIView class methods. So you say UIView dot animate with duration, okay? And inside there, you're going to provide a block. And inside that block, you're going to change one of these three things, okay? And it's going to animate that change over time. Okay, and it animates it in a very configurable way, as you will see. What's interesting, though, is even though you're going to give a block to these methods and it's going to animate these changes, it's going to execute that block you give it immediately. So these values are going to change instantly to the end point of your animation. So even while the animation is happening on screen, they're already changed. Okay, that's something really important to understand about how animation works in general, even core animation. When you change things, they change immediately. It's on screen is really just taking your time to show the user what the world looks like, okay? You're not actually, the animation doesn't change the things over time. It only shows the change over time. Okay, important thing to understand there. So here's the method, or one of the methods, the kind of the ones with the most arguments here, animate with duration, right? Class function on UIView. You can see here that it has a time interval for how long this animation is going to take. You know, is it going to take 2 seconds, half a second, or whatever? Also, you can delay the start of the animation, like start this animation 2 seconds from now. Why would you ever want to delay that? Because maybe you're going to have some other animation going on during that 2 seconds. Okay? So you might have 3 or 4 animations that you queue up, one of them to start in 2 seconds, one starts right now, it takes 2 seconds, whatever. You can do that. So that's why you might want to delay the start of it. Then options we'll talk about later. Here's that block I'm talking about. animations, this first green one here, takes no arguments, returns no arguments. You can put anything you want in there that changes the frame, the transform, and the alpha. Okay? And then completion is another block. Okay? It has an argument to the block, which is a Boolean, whether it finished this animation. You asked it to change to some endpoint. If it got there with the animation, then this will be called with this true. If it got interrupted somehow, and I'll talk about how that can happen, then this will get called with this finish being false. In other words, I wasn't able to complete the animation of those things you changed. All right, so here's an example of calling this. Let's say I have a view, my view, and it has an alpha of 1. In other words, it's fully opaque. And if I get to this piece of code and I find that my view is fully opaque, I'm going to make it fully transparent and then remove it from the view hierarchy. Remove it from its super view. Okay, to take it right out of there. Okay, that's what I'm going to do. So it's going to take 3 seconds for it to fade away. Okay, I'm going to be animating alpha here. But I'm not going to start for another 2 seconds. I don't know why. Okay, again, maybe I'm making the view spin around for a couple seconds before it animates out. I don't know. Here's some options. For example, here the option I'm using is curve linear. That means the fade out is going to happen linearly. Okay, it's going to fade out from 1.0 down to 0, which is where we're going, linearly, evenly, okay, smoothly. There are other curves that you can do, and I'll talk about that in a second. Here's my block. In my block, I just set my alpha to 0. That's where I want it to be eventually. Okay, so I set it to 0. Now, again, when I call this, it immediately sets alpha to 0. Alpha is not going to be set to 0 in 5 seconds. It's going to be set to 0 now. It's just going to appear on screen in 5 seconds. And then the completion here, I'm saying if $0, which means if it finished, then remove it from the super view. So if this animation of the alpha got interrupted by some other animation, then I'm not going to remove myself from super view. I'm only going to do it if I make it all the way down to 0. Okay? This block is going to be executed 5 seconds from now, or whenever this animation gets interrupted, if before that. Okay? So this block is going to be executed later. Notice I put print myView.alpha equals myView.alpha there. Okay? This is going to print myView.alpha equals 0, because this animate with duration executes this block and returns immediately. So myView.alpha is going to be 0. Okay? And it's going to stay 0 all the way through this 5 seconds that it takes for this animation to happen. Because this animation really has nothing to do, has no effect on the setting of alpha. It just is how we're presenting this change to the user. Okay, so let's talk about some of those options. There's tons and tons of options. I'm not going to go over all of them for time reasons here, but you saw curve linear there. Some other curves are like curve ease in, ease out. That means it starts off animating it slowly and then picks up to a normal speed and then slows down again at the end. That's a curve that we usually use for moving things. Okay, if you have a view on screen and you want to move it, so you're changing its frame, you're animating its frame, you don't really want it to go, okay, you kind of want it to pick up speed, move, and then slow down at the end. Okay? It's just less abrupt, it turns out, to do it that way. So you can specify that. Things like begin from current state, that's an interesting one. If you have an animation in motion, let's say our animation before, let's say we're halfway through showing the alpha going to 0, so it's half transparent, and then some other animation comes along and wants to animate it going to full opaque. Okay? If the other animation said begin from current state, then when it starts, it would start at 0.5, alpha of 0.5. Okay? In other words, it would grab onto the alpha of whatever animation's in process. You can think of this as begin from current state means use the values of these vars in the animation world, not in the real world. Because in the real world, the alpha is 0. It was 0 as soon as I set it to 0. So if you don't have begin from current state, then this new one is going to use the real world one, and it's going to be going to half transparent, back to 0, up to 1. Okay? Because if you don't put that begin from current state, it pays no attention to what's going on in the animation world. Allows user interaction, exactly what you think. Can you put gesture? You got some view flying across the screen. Can you touch on it while it's moving? That kind of stuff. You know, auto reversing, does the animation repeat? All these things. You can go look this up in the documentation for UIView. Okay, sometimes you want to make other changes to views, not frame, transform, or alpha. Okay? And you want to animate the entire change in there at once with some kind of cool looking thing on screen. For example, dissolve. You would want to change to dissolve in from the old, what it looked like before, to what it's going to look like, have it dissolve over time. Or have it flip over. Okay, like I'm going to use the example of a playing card. If you had a playing card and you change it from face down to face up, you'd like it to flip. Okay, you don't want to just boop, change to face up, change to that's very abrupt. You want it to kind of flip over. Okay, there's even a curl up. If you have a view that fills the whole screen, it can curl up from the bottom, like it's a piece of paper that someone's looking under. Okay, you've probably seen that sometimes. You do this with another UIView class method called transition with view. Okay, you specify the view like a playing card view or whatever. So this is the view that's changing. And then this is duration of the animation, just like we had the duration on the previous one, how long it's going to take for the card to flip over or whatever. More options, the same options as before. Here's the closure. Okay, this closure, this green closure here, it can change anything at once about the view. Okay, because it doesn't have to be restricted to those three that we know, because it's not going to actually animate any in-between states. It's just going to take the end state and the beginning state and flip between the two, or cross-dissolve between the two. You see what I mean? It's not going to show any intermediate positions of the frame moving around or anything like that, okay? So this can contain anything you want, and it also gets executed immediately, okay? Even though the animation will take time to show the flip, the change gets made immediately. And then here's completion, the same completion thing, and it'll let you know whether it finished. This one is almost always going to finish here. It's hard to interrupt in one like this. All right, so here's the playing card example. I've got my playing card view up here. I'm going to take a little less than a second. I'm using the transition flip from left option, so it's going to flip my card over from the left edge being lifted up and over. All I'm doing in my block is changing some attribute of my playing card view. Card is face up to not card is face up. So I'm toggling card is face up. Now when I do this, that's going to change the whole look of my playing card view from the back of a card to one of the front, cards face up. So essentially the system is going to take a snapshot of what it looked like before, take a snapshot of what it looked like after, and then do a flip animation to show the new thing, or cross dissolve or whatever other options you choose. Okay? So that's that one. Now, if you're animating a change to the view hierarchy, which is to say you've got a view in there and you're going to remove it from super view and replace it with another view, okay? Or you've got a view that you're going to hide and unhide some other view in its place, then you're going to want to use this one, transition from view to view. So the from view is the view that's in there in the view hierarchy that's going to leave, okay, or be hidden. And the to view is the one that's going to appear, all right? And here's the time, and here's the options, and here's the completion, okay? Now, if you use the option show hide transition views, then instead of removing it from the view hierarchy and adding the other one at the same place, it'll actually just set dot hidden, right? Remember the dot hidden var on a view, which makes it just not appear. It's still in the view hierarchy, but doesn't appear. This will set the dot hidden of 1, clear the dot hidden of 1, and set the dot hidden of 1 to true, and set the other one to false so that it appears, okay? So that's basically view animation. So let me show you a demo of that. And the demo we're going to do 2 parts here in face view. One, we're going to make our blinking actually be smooth. And to do that, we're going to use the flip. But instead of flip from left, I'm going to do flip from top. As you can imagine, if you had the eye open and you flipped from top, it would, more smoothly look like it's blinking. And then for the head shake, so I'm going to have this face, it's only 2D, so to shake its head, it has to turn its head sideways like this. It's going to shake its head, and to do that, I'm going to use the things where I change the transform, which is the rotation of that view, right? Remember, transform is scale, rotation, and translation, so I'm going to change that to make it shake its head, basically. Okay? Now, that's an interesting one because there's actually multiple moves there, and we're going to have to chain them together to make it shake its head. All right, so let's go back over to our face view, same place we were there. Now, to make face view eyes blink, all right, right here, these eyes need to be views, okay, because I'm going to use view animation. So if I want them to flip, okay, they're going to have to be views. So I have to change my code to turn these eyes into sub-views of my face view. Now, it's really not going to change face view that much, okay? Let's see what it looks like to do that. So to save a little bit of time, I created an eye view, which we're going to look at, don't worry, okay? So this eye view is just going to be a view that represents one of these eyes, Okay, so let's take a look at the UIView. Here it is right here. The UIView, this code in UIView is identical to the code I used to have in FaceView, or I still have in FaceView, which we're going to have to get rid of, which is this path for eye. Remember path for eye? We got either a circle or it was a line, depending on whether it was open or closed. If you look at this code here, path for eye, it looks just like this. Okay? Now, I had to bring over line width, color, and eyes open as vars in my UIView, which I'll have to set those from here in my FaceView. Okay, so I don't need this path for eye anymore because I'm going to use subviews to draw my eyes. This is also another way to show you using subviews of other views in code and how we do that. All right, so I don't need path for eye. I also don't need to do path for eye stroke over here because I'm not drawing my eyes in my draw rect anymore. I'm letting a subview of mine draw them. Okay. All right, so how are we going to do this thing here? So I have a little code here. This little piece of code right here. Okay, this is how we're going to do this. One, I'm creating a couple of vars, one for the left eye, one for the right eye. It's an UIView, right? UIView is just a UIView, okay, that draws those eyes. So it's an UIView. And I'm creating it by calling this method createEye on myself. Now, I'm going to take a time out here to talk about these lazies right here. If I take these lazies out, this will generate an error. Can anyone tell me why that's an error right there? Nobody know? What? Yes, exactly. Okay, we're in initialization right here. We're initializing these, and during initialization, self is not fully initialized. We can't send it any methods. Okay, we can't send createEye to self right here in the middle of initialization. Okay, this is part of this class being initialized. Until the class is fully initialized, we can't call our own method. That's why putting, by the way, the error message you get in here is kind of cryptic. This is kind of what it would look like. So if you see something like this, all right, then you might get the idea, oh, maybe it's that thing where I'm trying to call a method on myself while I'm initializing. So why does putting lazy in here fix it? Because lazy means that the initialization here doesn't happen until someone asks for this var. Okay, until someone asks for the left eye or asks for the right eye, these equals self-createEye are not going to happen. And no one is allowed to ask for these vars until this thing is fully initialized. So all is well, because now we can call this createEye to initialize it. So you see how lazy gets you out of that little conundrum of initializing there? And don't forget also you want to put self dot right here when you're doing createEye. Okay, if you're going to say this equals, you need to make it clear in your initialization that you're accessing yourself. All right, so this creates each of these two eyes. What does this createEye look like? Well, it's just going to create a new UIView. Right, I'm just calling the initializer here. I'm going to set it to be not opaque because my UIView doesn't draw a background or have any background set. So if there were something behind my UIView, maybe some eyeshadow or some eyeliner or something, it would show through. Also, I got to transfer the color and the line width onto the UIView. And in fact, I need to do this not only here when I create it, but I probably want to do it up here. If someone sets the color right here, in addition to doing set needs display, I probably want to set my left eye's color equal to the color, and I want to set my right eye's color equal to the color. And same thing here with line width. In addition to set needs display, left eye dot line width equals the line width, and right eye dot line width equals the line width. And interestingly, eyes open, of course, also we want to pass that along, but we don't actually need set needs display anymore for eyes open, do we? Because eyes open is no longer drawn by us. So if it changed, the UIView is the thing that needs to change. So here we just need to say left eye dot eyes open equals eyes open, and right eye dot eyes open equals eyes open. Okay? Sense there? Everyone understand why we don't need set needs display? Because we're not drawing the eyes anymore. We have a subview that does it for us now. Okay, so here we got the eye created. Now, after we've set the color and line width, then we're just going to add it as a subview of ourselves, which is great. Okay? Now, a little bit of a problem here. Where is this eye? Okay, we haven't specified where this eye. We created it with this initializer, which doesn't specify the frame. So it's like, we don't even know where this eye is. It's probably at 0, 0, and it's also size 0, 0. So we obviously need to position and size each of these two eyes, okay, to make this work. So I've created this little function right here to position an eye, okay? And it just takes the eye you want to position and where you want the center of the eye to be. Okay? Now it knows the size the eye is supposed to be because it has this skull radius to eye radius thing, so it's setting the size to that. And it creates a rectangle that's initially in the upper left with the proper size, and then it sets the eye's center to be whatever center you wanted. Okay? So it's a trivial little piece of code that just positions the eye. So now the question is, where do we call this position eye? Okay, where do we set the position of these eyes? I can't do it here. Okay, this create eye could be happening any time. I don't know what my bounds are at this point. My bounds might be 0, 0 also. So I even know where my eye goes. So that's no good. There's no view did layout subviews. Okay, this is a UIView, not a UIView controller. Okay, so there's no view controller lifecycle. We're in a view, not a view controller, so we can't do that. I can't call it from my controller. Here's my controller, because my controller has no idea that face view is using a subview to draw its eyes. Okay? If you go look back here in face view, all this stuff about the eye, it's all private, 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 private. It's all private. So there's absolutely no way my controller can reach down into me and do that. Okay, so this is going to show you how you find out when your view needs to lay out its subviews. Okay, it's a method called, conveniently, layout subviews. Okay, so layout subviews is the method in view that's called whenever the system wants the view to lay its subviews out. Okay, and those two eyes are subviews of ours, so we get to lay them out. Okay, so we'll call super layout subviews. Always nice to do that. Definitely want to do that for that. And then we're going to position these eyes. So we're just going to call position eye. Let's position the left eye. Where does the left eye center belong? Actually, believe it or not, from our old code, we have this get eye center method here. Okay, so we'll just use that. That tells us the center of the eye. Awesome. So we'll say get eye center, the left eye. Okay, and we'll do the same thing for the right eye. Okay, there we go. So don't be confused between layout subviews and view did layout subviews. Okay, view did layout subviews is part of the view controller lifecycle. That's a view controller thing. Layout subviews is a view method where a view is being asked to actually lay its subviews out. Okay, now a lot of time your subviews get laid out by auto layout, right? In that case, you don't need to do anything in layout subviews. But here, these eyes, we can't really put an auto layout for the eyes. Maybe we could. I'd have to think about that. Actually, it might be possible, believe it or not, but we're just going to do it in code, so you can learn how to do it in code as well. And so when layout subviews happen, we're just going to always be moving our eye to the right thing. Now, layout subviews is always going to be called if our bounds changed, because if our bounds change, we clearly need to lay our subviews out. This add subview right here is going to call layout subviews, cause layout subviews to be called, because anytime you change your subviews, you got to lay them out again. Okay? All right. So, see if anything else we want to do here. I think that's pretty much everything. Hopefully this will work. Let's see if this works. I just want to make sure I haven't broken anything. Obviously, we haven't done any animation for the eye blinking here, but hopefully we've replaced our view, or our eyes rather, with a view, and it looks like it's working. Okay? Got these. Let's see if we rotate. Yeah, it's all still working. Okay, so we haven't broken anything. So now we want to make these eyes animate closing and opening, okay, by using that transition flip from top. Okay, so how are we going to do that? So I'm going to do all that in the eye view. I'm going to be object oriented here. The animation of the eye, that's an eye thing. So that should be in the eye view. That shouldn't be in the face view. Okay, it should be in the eye view. So we're going to animate this thing right here, this eye's opening. Okay, we want to animate eyes open. So how are we going to animate eyes open? Basically, anytime an eyes open gets set, okay, we need to set it in an animated way. So I'd almost like to put something in did set, except for did set would be too late because it already got set. Okay, I have to animate the setting of it. I have to provide a little closure there, right, to that animate method that does the setting of it. So did set's a little too late. So I'm really going to have eyes open be a var that has its own get and set, so that in this set right here I can animate the setting. Okay? But I still need storage for the eyes open, so here's what I'm going to do, this trick. If you ever find yourself in a situation where you need to do something you need to animate the setting of something, or otherwise be involved in the actual setting, not the react to the setting, that's what did set is for, but you actually have to do the setting of it, and you make a public var like this that's computed, you can take the storage and put an underbar in front of it. That's kind of the convention we use to mean this is the storage for another property that is computed. Okay? We just call it underbar. So I still have eyes open. It's just that I'm going to set this in here animated. Right? I'm going to say underbar eyes open equals the new value in here, but I'm going to have to animate this happening. Now the get is just return eyes open. I don't have to animate the getting of this value. But this I have to animate. Okay, so how am I going to animate this? Of course, using UIView transition with view. Okay, so here's transition. See, there's the with view one, and here's the from view to view. So I'm going to use the with view. And we'll do the same thing we do when there's lots of arguments like this, so you can see them all. Okay, so we just have to animate the setting of this. Now, let's start with the actual setting of this. That happens here in this block. You see this animations block right here? So I'm just going to double click on this block. Here it is. And I'm going to put what I want to happen inside here. See, so I'm animating this change. Okay, this is going to complain that this needs to be self. That's because this is a closure. Okay, so we have to be clear. Now, is there any problem with memory cycles here? No, because this animation is only going to take a second, or less than a second, and then this closure is going to be gone. So there's no worries about someone holding on to it and it pointing back to us and keeping a cycle there. Okay? So what view are we doing this in? We're doing this in self. Okay, it's the UIView itself that is doing this being animated, right? It's being flipped over. And the time interval, well, we know that we close our eyes for 0.4 seconds. So our time of causing animating the change better be less than that. So maybe we'll say 0.2 seconds, something like that. We could play with these numbers. Again, I should make a constant for this, but for time, I won't do it. The animation options here we talked about, we want this transition. Make sure I find out what it's called here. Transition flip from top, I think it's called. Yes. Transition flip from top. Okay. The transition, and we could put other ones in here. Maybe dot, curve, linear, or whatever. Put whatever other options we want in here. And then completion. Once this thing has closed, we don't need to do anything. So my completion here is nil. Everybody cool with that? All right, let's see it work. All right, there it is. So you see how the eyes they're kind of squinching closed instead of jumping closed? Yeah. All right. So it's getting better by the second. All right, now let's do this head shake. So now I want this little head to shake. I don't know, he's saying no or something. I'm not sure what. But let's do the head shake. So the head shake we're going to do by changing one of those three special properties, namely the transform. Okay, we're going to have the transform of that thing changed. And I'm going to do that. I'm going to do that in my face view right here. Okay, it doesn't really have anything to do with blinking, so there's no reason to put it there. So I'm going to put it in my face view. And so let's do it so that it shakes its head when we tap on it. Right now, when we tap on our face view, it does this, toggle eyes. Right? If we go look at our storyboard right here, and we look at this tap gesture recognizer and right-click on it, you see that toggle eye is doing toggle eyes in our face view controller. So I'm going to disconnect that and create a new thing, which is going to be head shake. Okay, so let's do a head shake. Now, I want to put head shake into the face view controller superclass. Okay, I do not want head shake in blinking face view controller because it's not a blinking thing. It's nothing to do with blinking. Okay, but when I have this on automatic up here, okay, it picks the blinking face view controller. So how can I control drag to put this in the superclass? And the answer is just go to manual. Okay, if you go to manual over here and pick the face view controller, and then you try to control drag in here, we'll put it right near toggle eyes right here, it's going to work. Because Xcode is smart enough to know that even though this is a blinking face view controller, you're connecting it to one of its superclasses. Okay, so we'll make the tap gesture action here, we'll call it head shake. Okay, it's a tap gesture. Right, so here's our tap gesture right there. Let's go ahead and get the wider screen here. So make a real wide screen. All right, so here's head shake. This is going to happen when we tap. Okay, so here's where we need to modify our transform, and we know we want it to be animated. So let's start right off the bat by doing our UIView animate with duration. Now you notice there's quite a few animate with durations here. There's even one down here that has springiness in it, so that you can animate things springing, things like that. But we're going to pick the simplest one, which is right here. Almost the simplest one. Let's do the same thing where we put this on separate lines. All right, so here's our animate with duration. So here I am going to make a little private struct, which I'm going to be my animation constants. And so let's do a static let. Let's have the shake angle. So that's going to be the angle of the head that we're going to shake. And we'll go, let's see, it's going to be a CG float. Let's go pi over 6. It's going to be in radians. So we'll do pi over 6, which is a little bit of a head shake there. And then I'm also going to have the shake duration, how long it takes to move. And for that one, let's do maybe half a second. So it's going to half a second to move each direction. So it's going to take about a second and a half to do the full shake. Okay? So here, let's use our duration here, which is animation.shakeDuration. And here's our animation. Okay, so we're going to put our animation. This is where we're going to change one of those 3 special things. And then here's our completion, which is going to have this finished Boolean and then some code here when we're finished. Okay, and actually in this case, I'm not going to use, well, yeah, I'm not going to use trailing syntax here. This is an interesting thing to talk about. So this is one of the few times when I don't like the trailing closure syntax here, because there's really nothing special about this closure versus this closure. They're kind of equal in power. Maybe this one's even more powerful. So I'm going to keep them all inside here. Just kind of, to me, I think it reads a little better. But it's totally a style thing, whatever you want to do. All right, so in here we get to change one of these 3 things. Well, I'm going to change the transform of our face view. So I'm going to say face, oops, and I'm going to do self because I'm in a closure here. Face view transform. And I'm going to use this nice function called CG affine transform rotate. It takes an existing transform, which I'm going to take the face view's existing transform. Okay, transform is, remember, it's just a var in UIView. That's all it is, a var. And it encapsulates the rotation, scaling, and translation. Okay, so we're going to be messing with the rotation here. And we'll rotate it by this angle, which we know is our animation.head or shake angle. Okay, so that's going to do the rotation there. All right, let's see, what do we got here? What are we missing? Oh, completion. Oh, yeah, sorry, completion. It's part of that trailing closure syntax. It deleted the last keyword. All right, so everyone cool with this? Now, what to do in here? We'll see later. Okay, first we're going to see if this is working at all. So we're going to see, this is only doing the first part of a head shake. So let's see if that animation works. Okay, so our eyes are still blinking. They're still doing the flip from top. And if we click, sure enough, it rotated it by pi over 6. And in fact, if we click again, it'll keep on rotating. Now, notice the other animation keeps working completely independently. Okay, all animations, they're completely independent. They're only going to start interacting with each other if you're animating the same thing, the same transform, the same alpha or whatever. Here, these are completely different views. Okay, and even though that view is being transformed, it's still continuing to flip from top. Okay, which is kind of cool. Lets you build your UI animation very object-oriented. Just make each piece animate however it wants to animate. Okay, but our head shake needs to turn back the other way and then back to the middle. So how are we going to do that? Well, it can't turn back to the other side until it's finished turning to the right. Okay? So we're going to use the completion block to animate it going back the other way. So as soon as it's finished, if it's successfully moved over, if it finished, then we're going to animate back. Well, how the heck are we going to animate back? Well, let's just copy and paste this, because we know this, right? This whole thing right here does an animation. So we want to do almost the exact same animation. So I'm just going to copy and paste it right in there. The only difference is that instead of the shake angle going to the right, now it wants to go backwards times 2. Okay, it wants to go all the way back past the middle and to the other side. And then sure enough, when that one's finished, we want to do it again and get back to the middle. So we're just doing 3 transforms here, and we're just chaining them. Okay, in the completion blocks of each of them, we're just doing the next animation. That make sense? Right? So that's how we chain animations. So let's see if that works. All right, so here we go. He's blinking, and he shakes his head. And again, we could play with this. Do we want to curve in, ease out? Do we want to take a little longer maybe to swing back over, etc.? You can play with those numbers really easy in here just by setting options or durations. I didn't use the version of animate duration that had the options as an argument, but you could certainly add that back in. Okay? Any questions about that? You getting a good feel for this whole UIView based animation? All right. Okay. In the time we have remaining here, hopefully I can get us going on this next kind of animation, which is this physics-based one. So now let's talk more about animation. We're going to talk about dynamic animation, okay, which is this physics-based animation. And it's a little different approach than the UIView based. The UIView based, you're pretty much directly changing the things you want to change and then animating that change, okay? Here, you're just describing how things interact and then letting them go, okay? However they want to go based on whatever restrictions and physics you put upon them, okay? So here's how you do your dynamic animation. Here's the steps. 1, you're going to create a UI dynamic animator. This is the thing that does the animation. Very simple object to create, but it's very powerful implementation. It's the thing that actually is doing the animation. Then you're going to create UI dynamic behaviors and add them to the animator. Okay? Behaviors are things like gravity is a behavior. Collisions are a behavior. Pushing things is a behavior. Okay? Then you're going to add UI dynamic items, which are usually UI views, but not always, but 90% of the time. You're going to add those to the behaviors, and that's going to make those behaviors start acting on those items. Okay, so it's a 3-way thing there. Items get added to behaviors, behaviors get added to the animator, and as soon as those are all hooked up, things will just start moving. Okay, nothing else. You don't need to say go. It just automatically goes. As soon as you add it, it starts going. All right, so let's talk about each of those steps. First, creating the dynamic animator. There's only 2 initializers of it. One takes no arguments. That just creates a dynamic animator. But if you're animating views, if the UI dynamic items you want to animate are views, then you're going to want to create it with a reference view. Okay? And that's just going to be like your top level view usually, okay, where all the animation is happening. All right? So that's it. That's easy. Couldn't be easier creating a UI dynamic animator. Next, you're going to create the dynamic behaviors, okay? The behaviors, generally you create, their initializers take no arguments, okay? And so you just create them and add them to the animator here using add behavior, this add behavior method. Now, oftentimes you'll create something like gravity or the collider there, and you're going to configure it, because the gravity can be strong gravity or light gravity, like Martian gravity or Earth gravity, okay? You can change that. Same thing with collider. Obviously, you've got to decide what's going to collide with what, okay? But once you create them, you're going to just add them to the animator using add behavior. And then you add the dynamic items to the behavior, and you do that with add item on the behavior. So gravity, add item, collider, add item, gravity, add item 2. Now, if you did these 3 things right here, notice that item 1 and item 2 would both be affected by gravity, because I added them to that. But notice that item 2 would not collide with item 1. If item 2 and item 1 came next to each other on screen, they'd pass right through, because they're not both being affected by the same collider. Okay? Now, if I said collider add item 2, then they would smash into each other and bounce off. Okay? So which behaviors you add which items to really determines how they're going to interact. All right, so UI dynamic item. I keep mentioning this. What is this? I said that usually this would be views, UI views, but UI dynamic item is actually a protocol. Okay, and it has these three vars in it. Bounds, which is the bounds of the thing being animated. Notice that that is get only. Okay, so you cannot animate the bounds of something in the animator. However, you can animate the center, which is where it is, because that one's get and set. Okay? So the position of something in the animation world is animatable, but not the bounds, in other words, not the size. Okay? However, the transform, which views have, is settable. So you can rotate things, okay, and scale them, things like that, as part of the animation as well. So this, like I say, is usually a UI view, but you could actually animate off-screen things or things that you draw on screen using sprites or something else using this whole mechanism as well. Okay? But in this class, you're going to only do UI views. It's the most straightforward, obvious way to do it. Now, if you think about these being UI views, and they've been added to all these behaviors, and gravity is pulling on them, and they're colliding off each other and bouncing or moving all around. Maybe they're spinning around because they hit a corner of something, and their transform is being changed. If you want to change any of those views, if you want to change their transform or center, okay, then you have to let the animator know. Otherwise, it's going to be changing them to something else. And you do that by sending this message to the animator, which is update item using current state. And you pass the item. This would be a UI view, right? Because UI view implements this protocol. And then it will pick up whatever the current state is. So if you move the view to a certain spot, the animator would move the item to the spot in its world and then keep applying all the behaviors to it. Okay? But if you don't do this, you're going to be fighting the animator. Okay? So don't fight the animator. Work with the animator. Okay, so let's talk about some of these behaviors in detail here. Gravity behavior. So gravity isn't always down. Okay, gravity can be in any direction you want. Okay, you specify the direction with this angle right here. The angle's in radians. 0 is off to the right. So if you set your gravity angle to 0 and you put some views on there, as long as your magnitude is greater than 0, then everything will start sliding off, accelerating off, because gravity is acceleration, right? Everyone know what gravity is? Acceleration due to gravity, 9.8 meters per second squared, right? So it's going to start accelerating off to the right. So if you wanted it going down, let's say, down towards the home button, then you would want it to be, what, 3 pi over 2 or something like that? Yeah, 3 pi over 2, I guess, I know my radians, because you want it pointing all the way to down. Okay? We're going to talk about next week, what if you wanted it pointing where real gravity was? And once you know core motion and you know how to use the accelerometer that's in the device, you could actually be constantly setting this gravity to be actual gravity. And so all your things could fall, no matter where they turn their phone, things could fall down towards the Earth. And then magnitude is how fast the acceleration is happening. What's interesting is 1.0, a magnitude of 1.0 is 1,000 points per second squared. Okay? It's accelerating 1,000 points a second per second. That's how fast it's accelerating. This looks amazingly like 9.8 meters per second squared. Okay? If you put something at the top of your screen and let it fall at this magnitude, it'll fall very similar to how a real object would fall in space. And it's amazing that this round number is so close to 9.8 meters per second squared. But it's not. It's not the same thing, but it's close. All right, UI attachment behaviors. Okay, so what is this behavior? This behavior allows you to take two items or an item and a point and attach them. Basically attach them with like an iron bar between them. But the bar can pivot at either side, either at the point or at the item, or at the two items can pivot. So basically, if you want to think about two items, those two items will always stay the same distance apart, no matter what's happening to them. Okay? Now, if you had a point, a fixed point, and an item, and this item had gravity and an attachment behavior going on to it, it would fall down and swing. See why? Because it's always attached to this point, but gravity is pulling it down, and eventually it would settle down. That make sense? So attachment is basically a way to attach two things or attach something to a point. Now, what's really cool about it is, while things are happening, you can change the length of that attachment. Okay? right in the middle. So it's falling down, you could just pull it up in close, like a yo-yo, right? If you're doing yo-yo, you throw it around and you start pulling it in while it's still turning. Okay, you can do the same thing. You could build yo-yo quite easily here by changing the length of the attachment. Okay, the anchor point, okay, if you have a point in an item, that can also change. Like maybe it's attached to the finger using a gesture, and you're moving your finger around, and the attachment point is changing. It's pulling the other thing around with it. Okay, and I'm actually going to show that in the demo on Wednesday. So there's a lot of power in an attachment behavior. Collision behaviors, another thing obviously that you want, right? Let's say you're going to build your Homework 6, which is a breakout game. Okay, obviously the breakout game wants to collide with the bricks and knock them out, and it wants to bounce off the edge and bounce off the paddle. So you need these collisions, right? You can either have things colliding off boundaries. So like in your breakout game, the bricks would probably be these fixed boundaries. Okay, your paddle's probably a boundary that you're moving, all right? Or it can bounce off other things that are being animated, although you wouldn't want your bricks to do that, because your bricks, when you hit them, they disappear. They don't go flying off the screen. Okay, they disappear. Although maybe you would have them fly off the screen. I don't know. So collision lets you set up collisions between boundaries or between items. Okay? And you can have as many items as you want in there, things all bouncing off each other. The demo I'm going to do on Wednesday, we're going to have a lot of things colliding with each other. There's a nice little var here. A bool translates reference bounce into boundary. And what that'll do, it'll make a boundary which is the edge of your animator's reference view. Right? So the reference view, remember at the beginning, that's the kind of contains the whole space. You can make it so that it's basically a box. So everything that happens in the animation world, as long as you add it to this collision behavior, will stay inside that box. Okay? One thing that's nice to know about the collision is when a collision happens, and the collision behavior has a delegate, okay, which lets you find out when a collision happens. So you get this delegate method sent to you, collision behavior. Here's the behavior that's sending it to you, and it'll tell you that contact began or ended for an item with a boundary or for an item with another item. So there's this thing with item as well. Notice the type of this with boundary identifier, NSCopying. Okay, NSCopying is there for historical reasons, but suffice it to say, NSString and NSNumber are what is intended to be passed there, and we know that those are bridged to string and int and double, nicely bridged. So you can pass strings and doubles. The only tricky thing is that you're going to have to use as to cast this to be a string or an int or a double. Okay, because it's an NS copying. Small quirk of the API there. Next behavior is snap behavior. This is how you move something to a new location. So you got something sitting there and you want it to move over here. Okay, and it's called snap behavior because it moves over there, but when it gets there, it's like it's attached with 4 springs to its corners, so that it kind of gets there and goes, you know, kind of vibrates a little bit. Okay, it doesn't just slide up and stuck. Okay, it doesn't go kind of softly. And you can say how much the springs are dampened, whether it really shakes when it gets there or just kind of a little slight shake, whatever. But snap behavior is kind of the preferred way to move something from one place to another. Okay? Now, a lot of things might be moving because they have gravity and other things bouncing on them, but sometimes you have a stationary thing that you want to move. A snap behavior is a good way to do that. Then there's push behavior. Okay? Push behavior means push on this thing. Okay? And you can either push it once and see what happens to it, or you can continue to push on it. Okay? So that's continuous versus instantaneous pushing. And you just specify the direction, or you can do an angle and a magnitude, kind of like you do with gravity. And it's going to push it in that direction. So, for example, let's say you had a view, and gravity is working on it, so it's falling down the screen, and you pushed up on it with a certain amount of force. It would fly back up, but then gravity would still be working on it, so it'd come back down. You see what I mean? So pushing imparts a certain force to it, but if it's an instantaneous push, it's not going to apply that force after the initial push, and other forces are going to continue to work on it. Okay? Now, this is an interesting part about push behaviors is that if they're instantaneous, once you push on them, you kind of want to remove them as behaviors because they're dead. They're never going to push again. An instantaneous behavior only pushes once, and then it's done. So you want to really remove that behavior. And doing that, you kind of do that in an unusual way, and I'm going to talk about that in a few slides after I talk about a different method in a second. Then there's this behavior. Okay, we're talking about behaviors, right? Gravity and collisions. Here's one called UI dynamic item behavior. This is kind of a meta behavior. Okay, this has a bunch of vars like allows rotation, friction, elasticity. These are settings that you make. Okay, so all the items that are added to this behavior will kind of have these attributes. Okay, they'll be allowed to rotate. They'll have a certain friction. They'll have a certain elasticity when they bounce off other things. Okay, so these are really kind of affecting all the other behaviors, how the items behave when they are affected by all the other behaviors. So you can kind of think of this as a configuration behavior. You really are probably only going to have one. Each item will be in one item behavior. It is actually legal to have multiple item behaviors on same items, but you better be sure that you understand how they're interacting with each other. Generally, though, we kind of think of them as just settings for the items, how they're going to behave with collisions and all these other things. The UI dynamic item behavior, you almost always have one, by the way, because you want to set these things. It's also really cool because you can ask the dynamic item behavior for any item that's added to that behavior. You can say, what's its current linear velocity? Okay, I got some view, it's bouncing around the screen because it collided and gravity is pulling on it, and I want to know what's its velocity. Right now, at this instant, how fast is it moving and in what direction? Okay, so that's really nice to know, especially if you're going to pause your game or pause what's going on and then continue. You want to grab its linear velocity, stop the animation, and when it starts again, set the linear velocity back to what it was, because you can set it as well by adding linear velocity back in. You can also find angular velocity if the thing is spinning. Okay, how fast is spinning? Spinning really fast or just kind of slowly rotating, whatever. Okay, UI dynamic behavior as opposed to UI dynamic item behavior. The last slide was UI dynamic item behavior. This is UI dynamic behavior. This is the superclass of all behaviors. Okay, and you can create your own behaviors as a composite of other behaviors by using this add child behavior method in UI dynamic behavior. So you simply subclass UI dynamic behavior, add child behavior for all the composite behaviors you want, the gravity and the dynamic item behaviors and collision, whatever. You add all those child behaviors and then add any items to all of those behaviors, and you've created a composite, a new kind of behavior which collects all those into one. And if we have some set of behaviors that's operating on a whole bunch of items, we are very often going to create our own little composite subclass. And I'll do that in the demo because it's pretty common. Okay? One thing that's cool about UI dynamic behavior is it has a var called dynamic animator, which will get you the UI dynamic animator that this behavior is in. Because remember, we add behaviors to dynamic animators. It's like the second slide I showed you. So you can find out what it is. And in fact, it'll even tell you if you move to an animator. That's usually the animator being taken away from you because they want to stop animation, or added back to you to continue animation. Okay, so that's a good way to find out that that's happening. Okay, UI dynamic behavior also has a really cool var called action, which is a closure. Okay, you can set this closure to anything you want, and every time this behavior does anything, it's going to call this closure. So some behaviors call this thing all the time because they're always acting on the particular items. Okay, so you want to be careful to make sure whatever's in this closure is really efficient. This is one of those cases where you do want to kind of think about optimizing prematurely here, because this could be called a lot. So you don't want to do anything expensive in here. Okay, but it's really kind of cool because you can then do things as the animation is happening. Finding out as things are happening in the animation, you can be getting involved. Okay, so it's really kind of a cool method. Now, one of the uses we can do for this is that push behavior conundrum. You got an instantaneous push, it's already pushed, now you want to remove it. Well, this would be a great way to do it. Just have an action on that push behavior that set the action of the push behavior to remove itself when you're done. And this is what it would look like. Oops, no, oh, sorry, one more thing before I talk about that. This is the dynamic animator also has a delegate, and it'll tell you when the animator paused or resumed. Now, what causes the animator to pause? It's when all the objects reach stasis. In other words, none of the behaviors are causing any of the objects to change. Okay, then it pauses. As soon as a push comes in or something like that, causes things to start moving again, it will resume. And so you can find out when things have reached a steady state and when they resume using these delegate methods of the dynamic animator. Okay? All right, back to that push thing that I was talking about. All right, so here I've created a push behavior with a certain magnitude and angle, right? And look what I've done. I've set the push behavior's action to be remove this push behavior from the dynamic animator. See that? Okay, and since it's instantaneous, see how it's mode instantaneous? This is fine. I want this thing removed. I don't want it sitting around there collecting dust because it's not going to fire ever again. Okay, it fired, the action method got called. I put this closure in here to do this. But of course, this has a memory cycle, a really bad one. Okay, because this push behavior has a var action, which is a closure. So it has a strong pointer to this closure. Push behavior's action is a strong pointer to this closure. And this closure references the push behavior. So it has a strong pointer back to the push behavior. So this will happen just fine. And now the only people pointing to this push behavior, since it got removed from the dynamic animator, the only thing pointing to it is this closure. And it's pointing to the closure. So they're keeping each other in the heap. Okay? So this is our classic memory cycle. And just to remind you how we break it here, we're just going to put unowned push behavior in here. Because we know that this can never be out of the heap when action is called by definition. Okay, action's only called when this push behavior does anything, so it has to clearly still be in the heap or it wouldn't have done anything. Okay, so we can just put unknown push behavior, boom, breaks our cycle. This was just a refresher course in breaking memory cycles. Okay, I made it. Okay, so as before, here's what we're doing coming up. If you have any questions, I will be here as usual.
For more, please visit us at stanford.edu.